Okay, today's lesson is looking at calculating probabilities using z-scores, and it's trying to put it all together a little bit where we're starting to look at what if we get z-values on both sides, and what does that look like, and how do I answer it. So both sides questions, relatively straightforward. You'll be given a z-value that's on the right-hand side, and we might call that z1. And then you will be given a value on the left hand side, which might be Z2. Now, and all we have to do is work out the distance from the mean of one of the Z values, and then do the same for the other Z value, and then we just add them together. So what this means is that you'll get a question where it will be between two values, but the value is not the mean. The other thing that's less likely is that you're not going to end up with the same value either side, so it's not going to look symmetrical with the area that you have to work out. But if you follow the procedures that we've gone through, it's just a little bit extra of doing it twice rather than just once. So let's have a look at an example. So again, we've got our sheep weights normally distributed with a mean weight of 84.1 and a standard deviation of 4.6. What is the probability that a randomly selected sheep has a weight between 83.042 and 88.24 kilos? So steps, as always, draw the picture. So put in the mean, which we know by now is 84. And we know the standard deviation is 4.6. Now, until you get used to it, it might be worth thinking about these in terms of labeling them as Z. I'm going to try and color coordinate them as well. So Z1 in this case is going to be less than 84, which is 83.042. So that would represent that area in red. Now, the second value, which I'm going to call Z2 in purple, 88 is bigger than 84, so we're going to put it up here. And that's going to represent that area. Alright, so that's the situation. We've got these two areas we've got to work out and add them together. So the next one is calculate the Z-score, so using a formula. So that's going to require two different calculations. So firstly, we're going to find out what Z1 is by going 83.042, take away 84.1, divided by 4.6, and get our answer. Then second of all, we're going to find Z2, which is equal to 88.24, take away 84.1, so same calculation over 4.6, and get our answer. So we put those numbers in the calculator. So for Z1, the red, we end up with minus 0.23. Z2 for the right, and purple, we end up with plus 0.9. The next thing to do is have a look at our table and then find the values. So 0.23, so 0.23 gives us this area is equal to 0.0910. And then for 0.9, we can just see it there, is that it is 0.3159. So now that we know the probabilities of each one, we just need to add them together. So the probability that x is less than 88.24 but greater than 83.042 is equal to 0.0910 plus 0.3159, which gives us a final probability of 0.4069. So that leaves us with our last step: write the probability in context. So the probability that a sheep weighs between 83.042 kilos and 88.24 kilos is 0.469, or 40%. And that's it. So it's really nothing new, just having to add two bits together. So as always, there's a second question here. The density of Pounamu is normally distributed with a mean of 3.3 grams per cubic centimetre and the standard deviation of 0.011 grams per cubic centimetre. What is the probability that a randomly selected piece of Pounamu's density is more than 3.2912 and less than 3.30935 grams per cubic centimetre? So have a go at it, and then I'll go through the answer. Okay, hopefully you had a go at the question there. First step, draw a picture. So hopefully you ended up with this picture. So the key thing is that this is going to be Z1 in red, and we've got Z2 in purple. So the next thing is calculate the Z scores using the formula. So after doing that, we get for Z1 we get minus 0.8, and for Z2 we get plus 0.85. So looking at our tables, so 0.8, 0.8. 0.80, which gives us 0.28. And then for our purple, we get 0.8, so it's this one as well, but it's 85, which is there, which gives us 0.303. So now that we have the probabilities, we can work out, so the probability that x is greater than 3.2912 and less than 3.30935 is equal to our left-hand side probability 0.2881 plus 0.3023, which, don't forget the 1, which adds together to make 0.5904. That leaves us with our final task is to write the probability in context. The probability of a polynomial having a density between 3.2912 and 3.30935 grams per cubic centimeter is 0.5904. So hopefully that's what you got. So just revising the steps. So draw a picture. In this case, it's two areas either side of the mean. Put the mean in there as well. Calculate the scores using the formula. Get the probabilities from the table, and then write the probability in context. The probability of X being between and is. And that's it. So there's some questions in the workbook for you to have a go at, and there's a few extra, it's slightly bigger task for you to complete. There's also a worksheet with just the Z numbers which you can complete as well.